Okay, guys. So in this class, we are going to consider a continuation on the completing of the square method. This is now an extended part of our completing the square. This time, you are being asked to solve for x by completing the square. To solve for x, that is to determine the value or the values of x as we are given our equations. You're supposed to determine the values of x because that's quadratic equation that you're dealing with. Give your answers correct to two decimal places, meaning to say some answers are not exact. You're supposed to have your answers to two decimal places. Okay? So we are given for questions 1 to 8, from question number 1 up to question number 8, say whether the roots are real, rational, real, and irrational or non-real. Like as you consider your solutions at the end, are these roots real and rational? That is what you're being asked. Are these roots real and irrational, or are they non-real roots? Okay, so this is the instruction that you have thereafter, but how to solve? I talked about this in our previous class, how to complete the square, not to solve an equation. It was completing the square. Okay, so this time it's solving. Number one, we are given x squared. This is what we have, x squared minus 6x minus 12. That's equal to 0. Solve for x. You can use your quadratic equation to verify, not to use it on solving. No, the method is completing the square method. So I'm going to explain with the idea of our previous explanations. Remember when we're dealing with an expression where you complete the square. This time it's an equation. I just want you to get rid of one or two things here, depending with maybe the way that your teacher have explained it to you. But I'm going to explain it this way. Make sure that the coefficient of x squared is 1. The coefficient of x squared must be 1. Okay, remember that. The coefficient of x must what? Of x squared must be 1. The coefficient of x squared must be 1. Exactly equal to 1. When it is not 1, then you are supposed to factor that, divide, because it's an equation. The advantage is that you can divide that equation. All right? That's the advantage that we have this time. It's an equation. So instead of you factoring out, divide by the coefficient this time, okay? If it is not 1. Then we can actually do the same way like previously, finding out the coefficient of x, this and that, then you add and subtract that. But on an equation like this, you can simply take the constant to the other side of the equation, okay? So you can simply take the constant, to the other side of the equation, to the other side of the equation. Meaning to say, in this question that we have, the coefficient of x squared is 1. This is fine. So we're just going to take the constant minus 12. This is our constant. So you're going to have minus 6x. Take it to the other side of the equation. It is going to be a plus 12. So this is equal to 12. Then complete the square on the left-hand side. complete the square on the left-hand side. All right. Why am I saying complete the square, not writing the stage? Because those stages are the ones that I explained in our previous class. Remember, in our previous class, we started with something like this. X squared minus 6, this and that. You complete the square. How do you complete the square? The process, guys, you have to find half the coefficient of x squared, which in this case, we're going to have half of what? Minus 6. Squared like that, which is going to give us what? A negative 3 squared. And this is equal to 9. Like I said before, guys, you can add this and subtract. We are supposed to add and subtract. Add and subtract. So I want you to see that part of completing the square, that when you added, it was going to be like this. X squared minus 6x. You add the perfect square, this one that you had here, the half that one. So it's going to be plus minus 3 squared. You subtract that square again, and this is equal to 12. Like, this is what you're supposed to actually have done. This is exactly what you could have done. But in this case, we can see that the 12 there that we are having is not even part of this expression, and this minus 3. So we can take it to the other side of the equation. So instead of us adding and subtracting that, we could have just added both sides. The half coefficient of x, we could have just added both sides. So if you understand that way, just edit both sides. If you understand this way, guys, the completing of the square differs with the way that your teacher have explained. There's so many ways, still giving us the same thing. So on the completing of the square method there, I'm not going to talk much because I refer to this. So let's have our stages. So you can take this minus 3 to the other side of the equation. But as we do so, take note that this part can be factorized. Remember, this is the part that we can factorize as we had from our previous class. So if you did not watch that class, make sure that you watch the class so that you understand this stage of your factorization, where I said you're just going to take the first term and the last term. So there, do factorize. Do not limit yourself there. Factorize x minus 3 squared is equal to what? Remember, we are taking the minus there to the other side of the equation so that it will be a plus. So we'll be having plus minus 3 squared, which is simply what? 9. Remember, minus 3 squared is 9. It's equal to 12 plus 9. The number that we are having there is 9. So we're simply going to add, which is 21. So that's what we have at the end. So guys, the completing of the square, this part here, let's do revise as many questions so that we can actually understand this part. All right, make sure that the coefficient of x squared is 1. You can take the constant to the other side. You could have even left it here, this 12. We could even have left it here as a plus 12. When you add this, you know it was a minus 12. When you have it, you know that there's a minus 12. There's a minus 12 here. Then you take them both to the other side of the equation. If you understand it that way. The way of solving, guys, is actually in your hands. So also I'm gonna explain, try and explain. So this is where you are. You can introduce the square root to remove the square. Remember, now we are solving. Introduce the square root to remove that square. So that's equal to the square root of 21. And we do understand that the square root, so that's plus or minus the square root of 21. So taking the minus 3 to the other side of the equation, minus 3 jumps the equation, plus or minus the square root of that is where possible. 2 decimal places. If this answer in said form, if they say in x can be written as 3 plus the minus the square root of 21 from the plus or minus. In said form, you're done. But because they want these answers to be to 2 decimal places, you can use your calculator now thereafter to simplify that. That is to add the ones that we are given. So let's add 3 plus square root of 21. So that's 3 plus the square root of 21 like this. Okay, then we're going to change this to a decimal. As you can have your answer, it will be given in that same format. Change this to a decimal. That's 7,758 to 2 decimal places. You can also fix your calculator to 2 decimal places. That's shift. You go to the setup. All right, fix on number 6. Then you're going to press 2 to 2 decimal places. So let's change this. It's 7,58. So as you can see, our answer is already rounded off to 7,58. We are having 7,58, or another x is going to be what? On a negative value. Let us change this to a negative. Sorry for that. This issue of network sometimes. So that's a minus there, which is minus 1,58. Minus 1,58. And we are being asked to tell the final answer that we are having there about the roots. Are they real? Are they real and rational? Are they real? And just to have your answer, maybe it's a 2, it's a 3, it's what? It means your solution is already a real, so just cannot be determined. That's non-real. But just obtaining the square root of a certain number, it means you are having what? A real solution. So the second stage is, can we write our answers in the form of A over B, where A and B are whole numbers? This is impossible from what our answers remained like this. We cannot simplify that. So meaning to say, these are irrational solutions that we have at the end. So it's real and irrational. That is what we have, real and irrational at the same time. If it is real and rational, it must be numbers like those 2, 3, those are whole numbers that you can consider as real. So this is what you can have, guys. It's 12. Some of us, we might say, okay, what if we maintain the 12 the way that we are used to when we were completing the square? Because when we were completing the square, there were expressions of that nature, isn't it? Very true. They were there. So this is it, guys. If you do not want to have challenges because of the textbooks that you might be using, in the previous class that I referred, I said you can complete a square when you're given something like this. Just to complete the square, the way that you used it to, just forget like we are working with an equation. Put that aside. Put that aside. Is the coefficient of x squared 1? Yes. So meaning to say we need to have what? The coefficient of x. The coefficient of x that we could have just maintaining our completing of the square method the way that we did in our previous class. This is what we're going to do. All right. So half of minus 6, that's minus 3. That's to add and subtract this perfect square half. Add and also subtract what? Half the coefficient of x. Coefficient of what? Of x squared. Which is same as what? Minus 3 squared. I talked about a reason why I do maintain that as minus 3 squared instead of writing it as a 9. That's x squared minus 6 squared, which is the 9. We can write it as 9, okay? Then subtract it at the same time. That minus 3 squared. I have to add and subtract it. The rest is 0. As we had in our previous class. Don't forget about this taking of the 12 there. No, leave it like that. Then what did I say? I said you factorize this quadratic expression that you have formed from x squared to the part that you added, the square that you added there. And factorizing those two, you simply take the x, which is being raised to the exponent of 2, and the number that is also there being raised to the exponent of 2, which is x and what? Minus 3. All right, so the minus 3 squared. We have factorized this. You factorize this. You're done. You factorize. So what is remaining has to be simplified. This minus 9 minus 12. Because remember, this is minus 9 minus 12, which is what? Minus 21. This is what we have. Is equal to what? As 0. As you are used to that. This is the way that you can best work with. It does not interfere with it. Take this to the other side. You just complete your square as you are used to complete it. Forget about taking the constant there. At this stage now, that is where after you've completed your square, you can say, all right, what about this minus 21? What can I do with it? We are going to have x minus 3 squared, which is equal to a positive 21. It was a negative, it becomes a positive. So even there, we are going to have x minus 3, which is equal to plus or minus. Like I said, the square root of any number is what? Plus. So taking this to the other side of the equation, the minus 3, it becomes equal to 3 plus or minus the square root of a 21. This is what you're going to have at the end. Then you can simplify from there now, separating, as you can see, this is the same thing that we had before. So we're going to have 7,58 from a positive, 1,58 from a negative value, where these roots are real and irrational. So you see, the solving part is the same. It's just one of the same thing. So when working with the expression numbers, I think this is the best way that you can use just to maintain that. But when dealing with the other expressions, I'm going to talk about that later on. But for these ones, guys, we can maintain exactly following up what we had in our previous class. So you just see that it's a continuation as you had the previous time is what? Equal to 0 there to make it an equation. Otherwise, the rest is the same. So in this case, the coefficient of x squared is 1. Is half of what? half of 8 squared, half of the coefficient of x squared, and 4 squared is 16. We add, then subtract that. So it is going to be x squared is 4 squared. We also subtract that. All right. And that's equal to 0. All right. So let's say during the x and the 4, first and last term. So that's x plus 4 squared. It's a positive as it is. Then this is minus 4 squared plus 5, which is the same as we've got minus 16 plus 5. So just going to combine minus 16 plus 5 is 0. As we have this equation, we can take the minus 11 to the other side of the equation so that it will be a positive. So that positive 11, introduce the square root to remove this square that we are given there. We must have what? The square root. So that's the say, thus obtaining plus is equal to plus or minus the square root of 11. So let us solve from there to the other side so that it becomes a negative there. So meaning to say x is going to be equal to what? So x is going to be 11. So there we've got plus, simplify, just like the previous case on our calculators, having a negative from what we are given. Remember, we fixed our calculator to 2 decimal places. So our answers will be to 2 decimal places. Minus 4 plus the square root of 11. I'm going to start with the plus. So that's plus square root of 11. All right, to 2 decimal places, that will be minus 0.68. So we've got minus to be equivalent to what? To just put a plus this time, a minus this time. So let's remove this. Put a minus. That's minus 7.32. Minus 7.32. So this is what we have at the end. And with this simplification that we are having, x value, it means the roots are real. But are they rational? Roots are real and irrational. We can see it from the solutions. We do not need to cross-check with any method. From the solutions, we can tell that is what the question was all about there. So it means you just need to work out as many questions as you can. That is for you to actually understand these typical questions. Looking into question number 3, we can see that this time we do not have the coefficient of x squared as 1 as what we had before. There was a 1 here, but on number 3, this is 2. We have got a 2 there. All right, so this is what we are going to have. That is given as 2x squared plus 4x minus 8, which is equal to 0. So it follows that when working with an equation is different from an expression. If you are given an expression 2x plus 4 like this, you factor out the 2, then you remain with x plus 4, x plus 2 like this. It's an expression. You divide this 2x and 2, that is x, 4 and the 2, which is 2. If it is an equation that you are given, let's say we are given an equation such as 2x plus 4 is equal to 0 like that. Instead of you factoring out the 2 so that you remain with x plus 2, which is equal to 0, then after factoring out these 2, that is when you are going to divide by these 2, both sides, then you remain with x plus 2, which is equal to 0. We could have divided each and every term at this stage by 2. It's an equation. We're allowed to do that. We can divide each and every term, meaning to say we're going to have x plus 2, which is equal to 0. Then you can solve for x. So this is the same situation of the question that we are given here. We can see that 2 is common. So you can simply divide each and every term. Instead of factoring out the 2, you can divide by 2. In this case, working with an equation, you are allowed to do that. You can divide that by 2. So meaning to say, what are we going to have at the end? That is going to give us x squared, 4 and 2 is going to give us 2x, the minus 8 and 2, which is going to give us minus 4. That's equal to 0. We have our equation with the coefficient of x squared being what? A 1. So like I said before, the stages, just like our normal completing of the square method, we need half the coefficient of x. So that's half of what? Half of 2. we square that. Half the coefficient of x squared. And half of 2 is what? Is 1. 1 squared, which is 1. Remember what to do with that half the coefficient of x squared. We are supposed to add this and also subtract it from our equation. So that is going to be plus 2x. We subtract the 1 squared. Minus 4, as we are given, that's equal to 0. From there, factorize, working with the quadratic expression that we are given. So we have got our x squared, and this is 1 squared, the first and the last term. First and the last term. So what are we going to have? X plus 1 to the power of 2. Then simplify this part that is remaining. The minus 1 squared minus 4 is going to give us a minus 5. We can simplify that. So just like I said in the previous case, transpose the minus 5 to the other side. So meaning to say x plus 1 squared is equal to what? The minus 5 to the other side of the equation is going to give us a positive 5. So introducing the square root both sides means x plus 1 is equal to plus or minus the square root of 5. So like it's going to give us a plus or a minus. So let's take the plus 1 to the other side of the equation so that it will be a negative 1. So that's negative 1 plus or minus. You can simplify this. Evaluate the part of the square root. Starting with a positive, all right, let's figure out what are we going to have. That's minus. So we are given minus 1 plus the square root of 5. So to 2 decimal places, that is going to give us 1,24. So we've got if we are to change this to a negative, let's introduce a negative here. That is going to give us minus 3,24. So we've got minus 3,24. That is what we're going to have to 2 decimal places. So meaning to say, as we are working with our equations, we can solve these by completing of the square method and also tell the solutions after you've solved your equations, as we are given that we are supposed to tell that what are we having on the roots. We managed to solve this. So meaning to say our roots, they are real, but they are irrational. These and is in the form of a over b, where a and b are integers. It's impossible. All right, so guys, this is what we have. So an equation is different from an expression. Remember the expression to keep the 2. You factor out the 2. You work with that 2 up to the last or the final stage. You work with that 2 up to the final stage, which is different from an equation. If there's something that is affecting the, it is common, whether it is not common, you divide by that. It's the same thing as what we have on number 4. This is given as 5x squared is equal to 0, like that. So we can simply divide, just like what we had by 5, by 5, by 5, each and every term. All right, so this is what you're going to have to give us a minus 4. That's minus 4, and this one is going to give us a plus 4, which is equal to 0. And so I want you to try those other questions. So let's determine half the coefficient of x. Half of is minus 2 squared. And that is going to give us what? A 4. We add this and also subtract it. So that's minus 2 plus a 4, which is given already. That's equal to 0. So let's factorize this, working with the first term of x minus 2 squared. Simplify the remaining part of your quadratic expression. That means there we are going to have 4 minus 4 plus 4, which is a 0 there. That is plus 0. That's a 0 there. Here. From what we are seeing. From what we are seeing. Minus 2 squared. All right. That is the one that we had here. Remember this part here of minus 2 squared gave you a 4. So it's simply minus 4 plus 4. So on a condition that is like this, you must be careful. That's a 0 there. If you add, so that is x using the square root both sides, the square root, knowing that the square root of 0 is just a 0. We do understand that the square root of any number is plus or minus, equal to plus or minus 0. The square root of a 0 is just a 0. But plus or minus. Can we say plus 0? Can we say minus 0? 0 is just a 0. So we have got 2 solutions at a single point or at a single value. It is representing 2 solutions at a single point. So x will be equal to what? Minus 2 to the other side becomes a plus. So 0, you subtract a 0 from these 2. You add to 0 to 2, you subtract 0 from 2, you are still going to obtain 2. So that is the value of x. X is equal to what? To 2. So in a normal sense, there are actually 2 solutions that we are talking about to say x is equal to 2 or x is equal to 2. There are 2 solutions that are being presented there. There are two solutions. But in your writing, you can just write x is equal to 2. There are actually two solutions. And talking about the roots, 2, just obtaining a solution, like I said before, just to have a solution, it means the solutions, they are real. Just to have a solution, to obtain, to say it's 2, is 3, or what, it means the solutions are real. But is it rational or irrational? 2 is a whole number, which can be written as 2 over 1. That's a rational number, which can be written in the form of A over B. So we need to say our roots, they are real and rational. They are real and rational. 2 is just same as what? 2 over 1. It can be written as 2 over 1 as a fraction. So these are the questions that you're going to have. So I want you to continue with this question number 5. Let's see. There are other questions that I want us to work together. But for these ones, we can continue from there with any way that you understand from number 5. So there we're supposed to obtain at least our x being 3 over 2, or on number 6, we are supposed to have our x being 9, or another x being a minus 4. So I want you to try that. Number 7, I want you to work it out. You're going to see your x is going to be 4,73, or 11. Using the same way that you've been doing all these questions. On number 8, you do the same. But if there's any question that is a challenge, let me know, guys, on the comment section so that we can work that question separately on another class. On question number 8, you cannot simplify that. It is going to give you a negative. All right? This number 8, let me just do this one together. Number 8, because it's going to be something else. Number 8, we are going to obtain, we are given x squared. This is equal to 0. As we are working out this, we are going to determine half of minus 10, as we have the coefficient of x squared, which is 1. So we simply rush to the negative 10. What is that half of negative 10 squared? Half the coefficient of x squared. All right? So what is half of negative 10? Half squared, which is going to give us what? A 25. So this is what you're going to need. The minus 5 squared. Add that one and also subtract it. The square, the minus 5 squared. We also subtract that square, the minus 5 squared. But not forgetting that there is a 29 that you are already, his must be equal to what? To 0. So this is where you are. You factorize as usual, x squared minus 10x plus 5 squared, minus 5 squared, which is the 25. You factorize that part, working with the first and the last term. That's x minus 5 squared. You can simplify the remaining part that we are seeing. Remember, the minus 5 squared is 25, so it's the same as we've got minus 25 plus 29, which is a 4. So we've got minus 25 plus 29 there, which is a 4. So that's a plus. So we're going to have a plus 4, and that's equal to 0. Now with this equation, as we had all those equations before, taking the 4 to the other side, it's a plus 4. So it is going to be a negative 4 the moment it crosses the equal sign. So it's going to be minus 4. From a positive, it's going to be negative. Then introducing the square root, as we had previously, the square root here, the square root here. You're going to notice something on our calculators. We cannot simplify this, the square root of minus 4. Yes, we do understand the square root of any number is a plus or minus, but plus or minus what? We cannot simplify the square root of a negative 4. So it will remain as plus or minus the square root of negative 4. So this is our equation now. We cannot simplify this. We do not have a solution from that. So by transposing, the minus 5 is just a formality of solving our equation to say this negative 5 is going to be taken to the other side. So a root of a minus 4. But actually, we cannot simplify this, the square root of minus 4. Thus, in this case, solutions are not real. So this is non-real. Remember, when we're talking about the numbers from your grade 8, grade 9, dealing with numbers, you cannot simplify the square root of a negative. So that theoretically becomes non-real. Cannot be simplified. All right, so this one I just did to even, which are direct. You can just try to solve them. Then there are also these you are solving for an even, like considering your question number 9 plus qx plus r is equal to 0, like this. All right. So with this method that we had before, of completing of the square, when you are dealing with terms like this, where we do not have the numbers like what we had in this case when we're working with numbers that you're given there, in terms of the simplification, considering the first method, the first way that I worked that equation, that is the best way that you can work with when dealing with your quadratic expressions where we are given unknown values. These are unknown terms. P, we've got Q, we've got R there. We're supposed to be given these as numbers. So first things first, the coefficient of x squared must be 1. There we've got a P. So how can we make this to be 1? Divide by P. So we have to divide by P. Each and every coefficient of x squared becomes what? A 1. We must have this as x squared, not minus x squared, not 2x squared, x squared. This is what we need, which is not 1, supposed to be divided. Here we're going to divide by 2, we're going to divide by 3, because we do not have x squared. There's a number that is there. In this case, we've got what? P. So we divide by P. So that was going to give us x squared. Plus, this is, want to properly see the coefficient of x. So this is the coefficient. So that's q over p times x plus r over p like this. That's equal to, that's a 0, 0 divided by minus 2. That's a 0, any number. All right. So in this case, the procedures that we had was to find out the coefficient of x, which we are going to add and subtract at the same time. All right. Which is actually the major part that we have to remember. We have to find half the coefficient of what? Of x. The coefficient of x, which is a half of q over p like this, squared. So what are we going to have from this one? That's half of q, just multiply 1 times q. That's q over 2 times p, which is 2p. So that's q over 2p squared. So raising every term to the exponent of 2 is going to give us q to the exponent of 2, which is 4, p to the exponent of 2, which is p squared. All right, so this is what we are going to have. And this is supposed to be added and subtracted on our equation. So we're going to have x squared plus q over px. We add and subtract that, the square that we had, so 2p. So this is q over 2p squared. We also subtract that, q over 2p squared, plus that's equal to 0. All right, so we're going to take r over p. That's equal to 0 like this. So this is the part of the perfect square, which we could have written as this one, q squared over 4p squared. We can even write this one. If you understand it, it's one and the same thing. Dealing with the letters, these are not numbers. So simplifying these letters, there is also a technique that you need to understand. All right, so the factorization here is not going to change from this part. Remember your factorization. So you're going to consider the first term and the last term, the part that is being raised to the x, which is being what? Which is being formed. We formed a quadratic expression, which is the x squared plus q over px, this one. We factorize that. So factorizing this, considering the first, that is 2p. So you're going to have q over 2p squared like this. Then we are supposed to combine this. But like I said, it was easier for you to evaluate squared plus 3 over 8. You can easily add this, combine whatever that you have on a calculator. But this time you are dealing with algebraic expressions, and whatever that you're going to obtain here after simplifying is going to be a single term. So it is best that you do take these terms to the other side of the equation so that you properly work them on that side of the equation. Because you're going to obtain a combined term. Let's say we've got something like minus, all right, let's say we've got b squared, or let's say for bc. Suppose the terms that we are given to the other side of the equation, in doing that, it's a single term. The sign, you have to affect that sign, changing all these signs. Most of you, when it is like that, it becomes a challenge to work with. So it is best that you do transpose your terms here. Transpose those terms. Take this negative to the other side. It becomes a point squared. With a positive, it was a negative, so it becomes what? A positive. The r over p to the other side, it becomes a negative. The r over p. Then you can simplify the right-hand side, not forgetting that this whole part of q squared over 2p squared is p squared like this one. So in place of that, so let's try to just perform this addition, subtraction on its own separately. So let's see what we're going to have from our right-hand side. So that was going to be q squared, 2 squared, which is going to be r over p. We are back now to your subtraction, LCM, or finding of the LCD between 4p squared and p. So we're going to have this as what? 4p squared. Let's divide 4p squared into 4p squared. That's a 1 times q squared. So we are going to have q. So we're going to have, if we divide 4p squared and p, that's this one, we're going to have 4p times what? R that we have. So we're going to multiply 4p times what? Times r. So remember, your subtraction, you divide LCD to the denominator. Whatever that you get, you multiply to the numerator. LCD to the denominator, whatever that you get, you multiply to the what? To the numerator. So this is what is by simplifying the right-hand side. So meaning to say we're going to have x plus q over this part that we obtained on the right-hand side, which is q squared over what? Over 4p squared. This is where you are. So introduce the square root. Remember, the same way that we had, guys, the square, to remove that square, you need the square root. So we're going to introduce the square root and the square root that side, knowing that the square root of any number is a plus or minus, which is fine. Here it is just, so it's simply to remove the square. So you're going to remain with x plus q over 2p like this, which is equal to, you simplify now the right-hand side. From the concept of your sets, they allow you to divide square root A over the square root of b. Meaning to say, if you're given a single fraction like this, we can determine the square root of the numerator on its own. The square root of this numerator on its own. Can we determine the square root of q squared minus 4pr? It's an expression. We can't determine the square root of an expression. There's nothing that we can do as the square root of q squared minus 4pr like this over what? We move on to the denominator. As I said, the square root of a over b like this is the same as square root of a on its own over the square root of b on its own. So what is the square root of what is in the denominator? Can the square root of 4? That is 2. The square root of p squared is what? Is p. Remember, square root of p squared, we have got square root and the square root neutralizes. You remain with what? With p. So you have that square root. So you have to be careful now on the application of your sets. We can simplify this. The numerator on its own, the denominator on its own. And at this stage, now you can take the left-hand side, take this to the other side of the equation. It was a plus, so it is going to be a minus there. So x is equal to this as a minus on the other side. So that's minus q as the square root of what? When I have the square root of the remaining part, which is the square root of q squared minus 4pr like this, allows us to combine the numerators together. Remember that if you're given from your fractions a over b plus c over b, as long the denominators are the same, it enables us to add the 2a or the denominator, which is b. So you can see that we've got 2p, we've got 2p. The denominators are the same. So this allows us to add or just to combine the numerators together under the same denominator. Under the same denominator. So q is, our x is going to be equal to, that is going to be minus q plus or minus the square root of q squared minus 4pr like this. There's 2p here. So everything is over what? Everything is over 2p, just like that. So meaning to say, if you were to solve this, you are going to end up with an equation of that nature, which is your quadratic formula. Remember your quadratic formula, you end up with something like this. It can be of ax squared plus bx plus. They can ask you to solve that one. They can ask you to solve that quadratic, same formality that they just gave us in this man. It cares, all right? So I want us to check again here so that we can see how these questions can be given as. So if you are to consider these questions here, I want you to solve this. It was given as px. You solve it as ax squared plus bx plus c is equal to 0. The same way that I solved it by a each and every time, you solve with these letters, you are going to see that you're going to have your square root of b squared minus 4ac. Not getting that quadratic formula that you are used to, it means everything is wrong. So I want you to try with ax squared plus bx plus c and see if you're going to have the same thing. It is the same as what we had on this question, guys. It's only that this is p, this is q, this is r. I'm saying this time use it as a, x is equal to the 0. That's what I want you to have it like that. All right, let's check on number 10. Similar question to this one, but this time we've got negative kx squared minus mx minus n is equal to 0. As we can see on this equation that we are given, the coefficient of x squared is not 1. So like I said, divide by the coefficient of what? X squared, which is k. So divide by k each and every time by k here, by x squared minus m over k. So this is minus m over kx minus n over k. Half the coefficient of x. Considering where we have this part of x, I need half the coefficient of x. So that's half of half the coefficient of x squared. Half of minus, that's 1 times minus m. That's minus m. 2 times k. That's 2k like this one. It was going to give us minus squared. That's a positive. So that's m squared. 2 squared. That's a 4. K squared. All right. So we're going to have x squared minus m over kx. So we're going to add minus m over 2k over 2k squared. Remembering that there is minus n over k that we are already having there. Minus n, added this, then factorize. All right, remember these stages, guys, that I'm going to remove here. Then factorize as usual, factorizing our quadratic expression from x squared up to this one. We were going to have, that's x squared. There's a negative there. So use that negative as it is. All right, so that's x minus m over 2k like this squared. This part, I said you must simplify it, but as you can see, these are express terms that you work with. Where we back to algebra, we do not have numbers that we can actually simplify properly there on our calculator. So just take these terms to the other side of the equation so that you properly simplify them in this way. So the minus, take it to the other side. It is going to be what? A positive. This one, it was a negative. So it is going to be as a positive there. You ignore k squared. The minus n over k to the other side, it is going to be a positive. It was a negative over k like this. All right, so you can properly simplify the right-hand side 2k squared, which is equal to obtain a single term, a single fraction there. Must have a single fraction. So remember that the minus m over 2k squared, when you simplify this, it gave us m squared over 2 squared, which was 4k squared, k like this. So you can see that these two can simply be added together, just like the previous case that we had over 4k squared plus n over k like this. Consider m, that's 4k squared. So you're going to divide your LCD to this denominator. That's a 1 times m squared. That's m squared. So it's 1 times m squared. Plus 4k squared divided by k, it is going to give us 4k. So that's 4k times what? 10 plus 4k times n, which is 4kn or nk, whatever way that you're going to write there over 4k squared. Make sure it can be a negative, it can be a positive, whatever that you're given. Try to simplify that properly. So that was going to be x is equal to what we got here after simplifying this, our right-hand side, all right? Squared plus 4 squared. So this is what we obtained from the simplification of the right-hand side. So you combine until you have what? A single, when you introduce the square root to remove the square that you're given there. So we're going to introduce the square here. So this is going to be x minus m over 2k like this, equal to, by simplifying the numerator on its own, the denominator on its own. So the numerator, it's an expression, this one, m squared plus 4k, and it's an expression, square root plus or minus the kn, everything over the square root of k squared, which is a k. So that will be 2k, square root of everything. Then collect your terms. It was a minus, so it is going to give us a, and x is equal to positive, that's m over 2 m squared, everything over 2k. Combine this, like I said, denominators. You can easily combine the numerators, either that's m squared over what? Everything over 2 by 2k. It is because of what? The denominators, we are having same denominators. So we can combine the numerators, whether it is a plus, whether it is a minus that we are having there, we can easily combine our numerators together. So this is how our values of x can be determined under exam condition. They can give you a question like that. It does not mean that when you are answering typical exam question, they're just going to give you basic questions where you can just, where you're just given the numbers only. They can give solve. When you are given the letters, like what we can see on this question, where we had this k-squared dividing by the variable that you are given, as you had when you're dealing with the numbers, then be careful on the simplification of those algebraic expressions now to have a single term, a single fraction. 11, which is 2m x squared minus mx plus k is equal to 0. On this question, you're supposed to be very, very careful. Remember, I said you're supposed to divide by the coefficient of x squared because we do not have a 1. So you're supposed to divide by 2m, by 2m, by 2m, by 2m, each and every term. What we want of x squared to be 1. So the moment we divide like this, it's now a 1. It's now given as x squared. So for the rest of the question, do not be tempted to cancel the m wherever it is possible, even for you to cancel that letter m. By doing that, you are leaving out some of the terms which are important in your question. So you maintain with the m as if it is, as if you cannot simplify. We do know, guys, m minus m over 2m like this. We do know that they can cancel. But by doing this, you are making your calculations to be more difficult, as you have to work out, bring that m into an equation back. Yes, you can do that. I'm not saying it's wrong, but the simplification can actually totally differ from what it can be like. So do not cancel that m. Yes, you can cancel that m. I'm not saying it's wrong, but you see that your answers will be totally different. They'll be representing the same thing, but different answers. So I'm going to talk about that different questions as we'll be moving on. So like I said, for now, we want to avoid that. So we are going to write this as minus m over 2m. We're just going to write as if it's impossible for us to divide. But we know that it's possible for us to divide. But we just have to leave it like there you are. You have your algebraic equation that you need to solve by completing of the square method, with other expressions being left the way that you know that you could have simplified them, but you choose to leave them as they are. So we continue as usual, half the coefficient of x. So we're going to need half the coefficient. This is the coefficient of x minus m over 2m. So what are we going to have? 1 times minus m. That's minus m over 2 times 2m. That is going to be 4m. But remember, this is being what? Squared. Minus m squared is going to give us m squared over 4 squared, which is 16m squared. Do not cancel. You add and also subtract that perfect square, as I said before. M over 2m, we add our perfect square, which is just the same as this one. So you're going to add minus m over 4m squared over 4m squared. The remaining part as it was, so that's plus k over 2m, which is equal to 0 like that. So working with the left-hand side, need actually to factorize, just as we had our previous questions. So we're going to need to factorize x squared up to this part. So like I said, they just focus with the first and the last terms. So the first term, we've got x, which is part of x squared. The last cancel for now, just write as it is. Then we're going to cancel later on. So that is going to be x. This is minus m over 4m. Minus m over 4m like this squared. Leave it like that. Do not cancel the m and the m there, so that we maintain exactly what we are used to. All right. There we are supposed to have x here. Supposed to be x here. So this is where you are. And you're supposed to simplify this. And like I said, it is best that you take these terms to the other side of the equation so that you properly see how are they going to be like. The minus here to the other side, it becomes a positive. So we're going to have minus m over 4m squared. The k over 2m to the other side over 2m. So we're going to simplify. Remember, this minus m, guys, over 4m is this one minus m. So we know that after combining that, it is going to give us m squared over 16m. This, guys, that's m. It's going to be 4m squared is equal to, we square this, like I said, it's going to give us m squared over the 4 squared, which is 16m squared, minus k over 2m. This is where we are. And we need to combine this, the right-hand side, a single fraction, maintaining that part that as we had it. What are we going to have at the end? So we can say that here we've got m squared over 16m squared, between 16 and 2, that's 16 between m squared and m, that's m squared. So 16m squared. So you divide here, that's a 1. Then 1 times m squared, which is m squared. Minus, guys, if you divide 16m squared to 2m, 2 into 16, that's 8. M into m times k, which is 8mk like this. So this is what you are going to have at the end. So we've got m squared minus 8mk over what? Over 16m squared. As a single fraction. We're now having a single fraction, as like I said, that's x minus m over 4m, a single fraction. So as a single fraction, this is what we had it like that. So there we obtained like this over, introduce the square root here. So remember, so we're going to have x plus or minus the square root of any number as we know. The numerator, it's an expression that cannot be simplified. So leave it like that. So that's the square root of, the square root of 16. We know that. That is a 4. The square root of m squared is m. So it make the minus m be a plus. But looking into this, we've got minus the square mk like this. Our numerators are the same. It's going to be m squared minus. So that's it. Everything over 4m. The denominators, because they are the same, you can easily combine our numerators. Conditions can be of that nature. Can have conditions of that nature. If we could have simplified, solved this way, because somehow you might be using, remember these sources that you are using. Okay, if you see the last part of a quadratic formula, like in this case, do not cancel that. Do not cancel that part of m. But we could have simplified it that way. The answers, they're going to be mathematically in terms of the presentation different, but in terms of the meaning, that'll be the same thing. They'll be meaning the same thing, like the answers differently presented, but the person being the same. So let's see what we could have, how we could have worked out this. 2mx squared minus mx plus k like this is, so we could have divided by 2m by x squared minus, this time let's cancel the m and the m. Cancel that. It was going to be minus 1 over 2 x like this. And that is going to give us k over 2. Find out the coefficient of x. You square that is what? Which is a minus half. We square that one. So what is half of minus half? That is going to give us minus 1 over 16, which we are supposed to add and also subtract. 1 over 4 squared, we also 4 squared, plus k over 2m is our quadratic equation that is being formed, our quadratic expression being formed from the left-hand side, x squared up to this. So we're going to consider the x and the minus 1 over 4. So that's x minus 1 over 4 squared. Take it to the other side of the equation so that you can properly see what you are working with. The minus to the other side, it becomes a plus. So that's minus 1 over 4 squared with a. The minus to the other side, negative. So that's negative k over 2m like this. Your right-hand side, what are you can do? You just have 2 over 4 squared. The minus 1 over 4 squared. This one, 16 minus k over 2m. 16 and 2, the 16m divided by 16 like this. Your m minus 16 to the 2m like, so it's going to be 8 times like that. So this is what you're going to, everything over 16m. So this time it is that the numerator cannot be evaluated. We cannot evaluate that square root. This is an expression. And the denominator m squared, take note there. That is m, not m squared. So we cannot determine the square root as we had before. So this square root is just going to remain as it is like this. So you have your answer now as x to plus or minus. The square root remains as it is because we can't simplify any part there. This is 16m. We do not have the square root of 16m. No. If it's 16m, we can't determine that. So it will remain as it is, which is m minus 8 k like this over the square root of the other part of our equation, which is from the left-hand side to the right-hand side, to the right-hand side in that case, all right? This one becomes a positive. So therefore, x is going to be, so that's positive 1 over 4 plus or minus the square root of that part, which we cannot simplify. Remember, this part cannot be simplified. So this is what you're going to have at the end. The answers, like I said, they are mathematically different in terms of the presentation way that you see, but they represent the same thing. If we are to put a certain value of m and a certain value of k for both questions, we are going to have the same answers. This is to show that you maintain that part of m that I say do not divide from the first part that we had. I said do not divide this. We saw that it was perfectly presented at the end of the day. This one, the presentation, it will be something else, but does not mean that it's not correct what we expect it to be. But it can be like that. So number 12, I'm going to have the same presentation, 3k squared, 3kx squared is equal to 0 like that. I'm going to just divide by 3k as we is affecting what x squared. So divide by that. So that will be x squared as it is 2n over 3k. Let us properly see that over 3k. That's a positive there. Minus k over 3k. Just like the previous case. Do not divide the k and the k. Leave it like that. 3k, that's equal. Yes, you can divide, then you maintain the way that you have done it. I'm not saying it's wrong, but you can choose not to divide like this. Just leave it like that. We know that k and k can divide, but leave it like that. We find half the coefficient of x, this is that coefficient of x, 2n over k. 2n over 3k, we need that half squared. It was going to cancel. So it was going to give us n over 3k. So that was going to be n over 3k 3 squared, which is 9k squared. So this is your perfect square that you're going to add or subtract, or this 2n over 3k x. We add, then subtract our perfect 3k like this. We also subtract that n over 3k squared. All right, as it is, just leave it like that. That's equal to 0 like that. So this is it. Let's factorize where it is applicable, just like our previous situation. We have to factorize where it is applicable. So considering the x squared, that part of x squared as we have it here up to this part, all right? So that's x squared and the n over 3k there. All right, let's just try, guys. I think take this one as it is like this. Now see that can be written as x. This is n over 3k, everything being squared. To simplify this, it is wise enough that we do take it to the other. The moment we take it to the other side, it will become a positive. That's n over 3k squared as a positive. This one, so that's k over 3k like this becomes a positive. So we can simplify our right over 3k squared. This one is the same as what? As n, or as n squared over 9k squared from here. So over 3k squared, then combine this with plus k. Now our denominators, our fractions to have a single fraction actually. Need a single fraction here. So what are we equal to? All right. X plus n over 3k squared, and 3, that's a 9. K squared and k, that's a k squared. So let's divide 9k squared divided to 9k squared, that's 1. 1 times a plus 9k squared divided to 3k is going to 3 into 9, that's a 3. K and k squared is going to be k. So you're going to have 3k. The 3k, you multiply it to the k on squared. 3k and k, which is going to give you 3k squared at the end. So this is what we're going to have. And introducing the square root to remove the square that we are having on the left-hand side. Introduce the square root. So we're going to have x plus n. This method, you'll see that it will be possible for you to simplify the denominator. This method, there is no way. The denominator, you'll be able to simplify it, and you'll be able to have a single fraction also at the end. The numerator, yes, we cannot simplify that, so it will be plus or minus the square k squared, like this, over what is the square root of 9? That is 3. The square root of k squared, which is a k. We can determine that square root. Unlike the previous case, where we had another method, and that one, we cannot have even a single fraction. It will be another fraction to another fraction separate. But for you to have a single fraction like this, you maintain the 3k and the k and the k, you can see that it can divide, but you do not divide. You divide exactly the way that you are supposed to have, like the method that you need. So take the minus this n to the other side, it over 3k plus or minus 3k squared over 3k like this. It has together, like I said before, if we are given this, the denominators can be combined together now. The denominators are the same, so just combine the numerators. So combine the numerators together. So you're going to have minus n plus or minus the square root of n squared plus 3k squared. So this is what you're going to have at the end as a single fraction. This is where the solutions, the values of x, are going to be obtained for any value of k, for any value of k that you're given, or for any value of n that you'll be given, which satisfies the equation, which satisfies the values of x equations, like inside. Not as we are used to when we are supposed to be having normal numbers, a, n, whatever that we have. It can be like that even under an exam condition. So it is important doing as many topic, and also to revise questions if you are within the even typical. Try to attempt question papers under this completing of the square method. Check questions which are under completing of the square method and see if you are able to attempt those questions. Where there's a challenge, then it means you have to revisit as many revisions till we meet again.